Hello everybody. In this video I'll be working on three rate time distance problems. So let's start with this one here. A small plane traveled the 1,200-kilometer distance between two islands in 4 hours with the wind. The return trip against the same wind took 5 hours. Find the rate of the plane in still air and the rate of the wind. So you know you're dealing with a rate time distance problem when you are given a distance and a time and they ask for a rate. So this isn't digits or a number comparison. This is rate time distance, which means you're going to set up a chart. So your chart should look like R times T equals D. Oops, I don't know if I left myself enough room over there, but uh-oh, the doggy is whining. All right, so this is with wind, and this is against wind. A and W. Okay, so a small plane traveled 1,200 kilometers. That's a distance between two islands in 4 hours with the wind. So with the wind, 4 hours. And the return trip against the same wind took 5 hours. So we know it's 5. We also know since it's a return trip that it's the same distance. So we're just going to put 1,200 here. Now, the rate, because we're talking about wind and the plane speed and everything, with wind, we're going to say R plus W, or you could say P plus W to represent the plane speed. I'm just using R for rate. And then we're going to have rate minus W against the wind. So this sets up your two equations. It's this times that equals that. I'm going to put the 4 first because that's usually what our distributive property problems look like. Now, if you'll remember when we talked about these in class, these rate time distance problems often set up very nicely for a straight up elimination if we can just get rid of this 4 and the 5 first. And so that's what I'm going to do first. I'm going to divide equation 1 by 4 and equation 2 by 5 because that's going to make it look real nice. So that was equation 1 and equation 2. So for equation 1, the result of that is we get R plus W equals 300. And then for equation 2, we get R minus W equals, 240, I think? Yeah. Okay, so now if we add these, we get a real nice elimination because the W's are going to go away. So R plus R is 2R, W and minus W is 0, so we're just going to end up with 540 here. And then dividing by 2 gives us 270. And then we can just go right back up here. 270 plus what is 300, and that what will have to be 30. Okay, and so now we have our answer. It was that fast. So the rate of the plane, so the plane speed is 30, what is it, miles, kilometers, 30 kilometers per hour, and the wind speed is, nope, I lied, the plane speed is 270, and the wind speed is 30 kilometers an hour. Okay, and you can still test that, right? So if you're going with the wind, you're essentially going 300 miles an hour for 4 hours, which is 1,200. If you're going against the wind, you're basically going 240 miles an hour for 5 hours, which is 1,200 as well. So that you can still test these answers. All right, moving down. Once again, even if you weren't told this is a rate time distance problem, you're being told the distance, you're being told a time, you're being asked for a rate. So it's pretty easy to deduce that it is a rate time distance problem. So you're going to set up the chart right off the bat. Rate times time equals distance. Again, always labeling the chart with a heading. Chart obviously doesn't have to look beautiful because this one doesn't. Again, we're going, looks like with the wind, against the wind. So the rate with the wind, let's see, we're talking about a plane again. So this time I'll use P to represent the plane. So with the wind, it's it's plane speed plus wind speed, and against the wind, it's plane speed minus wind speed. A plane travels 2,080 kilometers between two cities in 5 hours with, and then the return trip against took 6.5. Again, still the same two cities, so the distance remains. So our equations are equation 1, equation 2. We have 5 times P plus W equals 2,080, and 6.5 times P minus W equals 2,080. And we're going to clean it up once again by, I'm going to divide this top one by 5 and the bottom one by 6.5. 6.5, well, that can be annoying. Yeah, but we'll make it happen. So 1 and 2. Dividing this by 5, we get, what, 416, I guess? So it's going to be P plus W equals 416. I did that by dividing by 10, which gives me 208, and then multiplying by 2, which gives me 416. This, I don't even know what's going on there, so I'll have to do some long division since my calculator's not handy at the moment. So I'm going to do that divided by 65, which is what, 120, 180, 195, so 3, 195, what is that, 8, 9, 10, 13, 130, oh, that's not too bad, 65 goes into that twice, 130, boom, boom, oops, 130, bam, so we're at 320, so P minus W equals 320. Once again, as usual, these rate time distance problems often add up real nicely for an elimination, and that's going to be 2P equals 736. Dividing by 2 gives me 350, 365, 368, I think. Let's see, 720, yeah, 368. And then backing up here, 368 minus what is 320, so it's 48 for the wind. Wind equals 48. So, plane speed equals, I'm going to get rid of this little calculation here. Boom. Plane speed equals 368. Are these kilometers? Yeah, kilometers per hour. And the wind speed is 48 kilometers per hour. We can test that because with the wind you're going 416 kilometers per hour times 5 is, yeah, that works, 2,080, and then 320 against the wind times 6.5, and let's see, 320, 6.5, 1,600, 1820. I think that works. Okay, so we're good. We're going on to the next one. Number 9, sailing now instead of flying. Does that change anything? No, it does not. We're talking about a boat here, folks. So it's going to be rate. It's going to be time. It's going to be distance. Same stuff. Make our chart. Same chart. Same beautiful chart with uneven lines here. We're talking about boat traveling downstream, upstream. So downstream means like you're going faster. So it's the boat plus the water. And then upstream is boat minus water. It's slowing us down. We're going 24 miles. Downstream in 3 hours. Upstream in 4 hours. Still 24 miles. Same stuff. We have equation 1. 3 times B plus W equals 24. 4 times B minus W does not equal 25. It's still the same 24. I don't know what I did there. That's kind of crazy. Boom, boom. 24. Going too fast. Okay. So I'm going to do the division. So equation 1, equation 2. Equation 1 is going to divide by 3, so we're going to get 8. B plus W equals 8. Dividing by 4 gives me 6. B minus W equals 6. Ooh, that's a B. That's a 6. Okay. We're going to use addition again because it just works so nicely. 2B equals 14. B equals 7. Super easy. Easy like Sunday morning, but it's Saturday. Boom. W equals 1 because 7 plus 1 is 8. And we can test our theory. If we go 7 plus 1 miles an hour, 8 miles an hour for 3 hours, or, oh yeah, it is miles. Yeah, 8 times 3, 24. If we go 7 minus 1 here, 6 times 4, 24. It's all good. So, speed of the boat speed equals 7 miles per hour. Water speed equals 1 mile per hour. Victory. See you for the next video.